Hi everybody, it's Alex here with my Module 6 discussion presentation. So after reviewing the course videos, I was inspired to do something also based on The Incredibles, just because I really like that movie. A new one just came out. I haven't seen it yet, but what everybody's talking about is all of Jack's powers. So I recalled from the first movie, and then there's a short that was kind of made right after it, but if you have the DVD, it's like a special feature on there. So he uses a total of like 7 different powers over the course of the first movie and that short. So I decided to do a probability distribution using the 7 powers he demonstrates. And then I wanted to random sample 3 of those. So say he uses 3 of them in succession at random. Um, what and then I wanted to pick out the morph powers. So like when he turns his body into something else. So what was the probability of him using 1 morph power, 2 morph powers, or 3 morph powers in the succession of these random use of powers, basically. So I assigned each of the powers kind of a designator. So teleportation was TP, levitation LE, wormhole WH, laser vision LV, and then morph fire, morph metal, and morph gremlin were MF, MM, and MG respectively. Also, just put some visuals in here because it kind of helped me remember what they all stood for and thought it'd be add some fun to the presentation. So I made this little chart over here just for my own reference. As you guys can see, there are 4 possible combinations in which he does not use any morph powers. There are 18 single morph, basically possibilities, and then 12 double morph, and only 1 triple morph. So there's 35 total power combinations that he could potentially use. And yeah, so I just kind of jumped in with that. Just did some basic division to calculate the probability of each one. So 4 and 35 for 0, 18 and 35 for 1, 12 and 35 for 2, and 1 and 35 for 3. Obviously there can't be 4, but I just kind of wanted to even the graph out a little bit. It kept dropping this space in over here that I couldn't get rid of, so just makes it look a little cleaner. So yeah, then you multiply that probability versus the number of morph powers used to get this value here. Ooh, I did not mean to do that. And then you got to do your differences, square them up, and then take the square root to get your, or no, excuse me, not your square root, just multiplication by the probability to get your basically total variance, and then you have to take the square root of that to get your standard deviation. So wound up with expected value of powers used in a random sample to be like 1.29 with a standard deviation of about 0.7. So when I graphed that out, it was, um, you know, pretty, pretty much what I expected. Lower number of 0 powers, very low number of 3 morph powers, and then kind of a much greater number of 1 morph power showing up in that random sample. So I dropped in a little triangle here, kind of like was done in the instructional video, just to show about where the mean or expected value would fall, and then kind of dropped a bar in around that to show we're getting up to about 1.99 and down to it's like about 0.59 for kind of where most of the data is sitting within an average deviation of the mean. So then after kind of doing all that and taking a look at it, I jumped over to do the empirical version of this trial. Basically, so rather than just modeling it, we're gonna run some different trials. I decided to do 100 just because it seems like the more you do, the more accurate predictions you get. So kind of ran all my trials over here. I had all the different powers laid out, and then just like in the instructional video, I just did the rand function multiplied by 1,000 and eliminated the decimals just to make everything easy to look at. Assigned some conditional formatting to make them pop red. Thought that fit well with the Incredibles theme. and then basically took the lowest three numbers as our sample. So you can see here we've got Morph Gremlin showed up. We also had the wormhole and the laser vision. So there's only one morph power used in that particular trial, and so I just kind of tracked those. Just went through. It made it really easy having all of the morph powers here on the left. So I was just able to quickly count how many were used in that trial, and just kind of ran down the list, did that. And then I did it's like a count if function for this portion of it. So you can basically tell it to, for this data range, you know, this whole data range was like K6 to K105. If it is this value that was in M6 here, so 0, count it, and then divide it by 100, so it's giving me the probability of that occurrence out of 100 trials. So the probability of 0 morph powers being used was 8%, 1 was 62%, 2 was 24%, and 3 was 5%. I think the total actually wound up equaling like 99, and that's just due to the rounding. Let me quick check that here. But because I was rounding, it's not going to be exactly 1, and which it should equal. But if we included all the decimals, then we would have that. So then calculated the mean expected value and the standard deviation. Just using, again, the data from this list. It's just a simple average function, standard deviation function. And it wound up being really similar to what I had shown in the model. You can see there's slightly less zeros showing up, and I think slightly less 2s, a lot more 1s showed up in the empirical simulation. And then I just inverted the colors here just to make it easier to delineate between the two. I'm going to pop over here real quick where I have them side to side. And just looking at them, you can see that they're very similar. The formatting on these charts wasn't identical. There's like a little extra white space here, and I couldn't recall how to get that to disappear. So they're not exactly identical, but they're very, very similar. And obviously, like I mentioned, you can see in the empirical one, we ran into a lot more of the one morph power being used, and kind of less of the others. But the expected value and the standard deviation were very, very similar. We had like a 1.29 over here versus a 1.26 in the model, and a 0.7 here versus like a 0.68 in the model. So there was not a whole lot of change there, which is sort of what I expected, just based on the way this is supposed to work. So I was glad it turned out that way, and yeah, that was pretty much my whole project there. Hope you guys enjoyed it, and the visuals of Jack terrorizing his babysitter there. Hope you all have a wonderful weekend. I look forward to discussing with you in the comment section. Thanks.